This is the last slide we didn't get to from the end of the section yesterday. So we did our operations with rational numbers, including finding quotients and identifying positives and negatives based off the signs. So I want to talk about real quick the equivalent forms of fractions. For the most part, if it's a negative quotient, where that negative sign goes doesn't really matter as long as there's only one of them. Okay? It could be a negative numerator, it could be a negative denominator, or you could put the negative out front. Does not matter. They all mean the same thing. Normally, personal preference, I like to put the negative out front. Just makes it nice, neat, and clear. Doesn't get lost with anything else. But again, and also negative in the denominator just looks kind of weird to me. But it's not wrong. It's just equivalent forms. Okay? So these three fractions are the same. They mean the same thing. All right? And then for the positive, if they're both numerator and denominator are negative, well, that's just a positive fraction. Okay, so those negatives, I guess you could say, cancel out and give you that positive fraction. So there's no need to really write the negative on both. The most important thing to know is that this and this are not the same. Okay. If you have a negative on both, it makes it positive. If you have a negative on one, it makes it negative. So you need to know the difference between those there. Okay? Questions, comments, concerns, queries, connections. Perfect. Now, let's roll into the real stuff. Full screen. Okay? So we're going to move into some of the higher order functions, the exponents, the roots, and we're also going to talk about the order of operations. So, excuse me. All right? With our exponents, we're going to have a lot of them. All right? We do a lot of stuff with exponents. It's just repeated multiplication. Okay? So I have 5 factors of 2. That means I have 2 being multiplied by itself 5 different times. So I have 2 to the 5th power. My base and my exponent. The base can be any real number. Okay? We're going to be dealing with any real number for the base. And the exponent, for now, is going to be a natural number. 1, 2, 3, 4, 5, those numbers. Okay? We can have decimal exponents, but it kind of changes the rule on the exponential expression. Same thing with negatives. We have additional stuff to keep in mind with that. So for the most part, when we're dealing with repeated multiplication, we have a real number base and a natural number exponent. All right? So paying attention to what the base is, especially when we have positive negatives, if we have variables or multiple variables. If I have negative 10 times negative 10 times negative 10, what is my exponential notation going to be for that product? Negative 10 to the power of 3. Now, how you write it is very, very important. Negative 10. Do I write it just like, well, with a 3, not a C? Just like this? Need to have the parentheses. Okay? These are not equivalent. Okay? I don't know why this thing hates 3s. Okay? Those are not equivalent. Alright, that parentheses is very important. That negative 10 is the base. So the whole thing needs to be raised to the power. Alright? What about for B? Y to the what? Y to the 8th. Okay? Y to the 8th power. Alright? Not so bad. Questions, comments, concerns? Alright? So let's look at evaluating now. So I have 3 to the 4th power. That means I've got 3 times 3 times 3 over and over and over. Okay, 4 times. All right, well, what's 3 times 3? And then 3 again. And then 3 again. 81. Okay. There will be some exponents that show up so much that you should kind of learn. Okay, 3 to the 2nd, 3rd, 4th power is really common. Okay, 3 to the 4th power shows up a lot. 4 to the 3rd power, any of the squared up to 12, maybe even up to 15, shows up a lot. And then for 3rd power, usually don't go past like 5. So 5 to the 3rd power shows up a lot. So knowing those common exponents is going to be crucial. All right. All right, so you guys are going to do B and C. So what I want you to think about when you're looking at B and C is notice the difference between them and how it's going to affect your final answer. Okay, so we're going to start with the quantity of negative 3 squared. Negative 3 squared. Negative 3 squared is negative 3 times negative 3, which gives me a positive 9. Negative 3 times negative 3 is positive 9. Now, what's going to be the difference when I have negative 3 squared? Negative 3 squared. The difference is parentheses or no parentheses. Don't pick 6, please. Okay. So, without the parentheses, negative 3 squared is a negative 9. I want you to try and tell me why. Why do you think it makes a difference? Why do you think it makes a difference whether I have those parentheses there or not? Okay? Why do you think it makes a difference whether I have parentheses there or not? Do the best you can. You got a few minutes. Negative sign's excluded when there's no parentheses. Okay, so the negative is not part of the base. Okay, if it's in parentheses, the negative 3 is the base. So it's negative 3 times negative 3. There's no parentheses, then my base is just the 3, and only the 3. 3 squared is 9, and then it's negative at the end. Okay? Alright, so that's what that breaks down to is, what is our base? Does our base include the negative, or is it just the number, and the negative is separated from it? Alright? Now, the inverse of squaring a number is a square root. The inverse of cubing a number is a cube. Fourth power is a fourth root. Okay? They're opposites, just like addition, subtraction. They undo each other. Multiplication, division, they undo each other. Square roots and squaring undoes each other. Okay? So, when we want the square root of 49, we have to say, okay, well, what number squared gives me 49? 7. But I can also do negative 7. Negative 7 squared also gives me 49. So our square roots always have two solutions. Okay, so which one do we choose? Well, depends on the problem. Okay, we have two types of roots. We have what's called a principal root, or the positive root. The principal root of 49 is 7. It's our positive root. We also have the negative root of 47 to give us the negative 7. When you're just given an expression with a radical, whether or not there's a negative sign in the front will tell you if it wants the principal or the negative. If the negative sign is there, then I want the negative root. If the negative sign is not there, then I don't want the negative root. I want the principal root. Okay? So, square root of 121 over 81. We can do the square root of the numerator and the square root of the denominator. What's the square root of 121? 11. What's the square root of 81? 9. Okay? And am I going to have a positive or negative fraction? Negative. Okay? Because it wants the negative root. All right? Square root of 49. 7. Is it going to be positive or negative? Positive. Okay? Negative square root of 49. Negative 7. And the square root of negative 49. 7. Okay, so I heard several right answers. This is where reading directions comes in handy. Find each square root that is a real number. Is the square root of negative 49 a real number? No, it is not. Negative square root of negative 49 is not a real number. Okay? So here, because it says find it if it's a real number, then we just have to write non-real. Okay? Because, right now we're dealing with the real number system. Okay? Will we do stuff with non-real numbers later? Yes, absolutely. Are we going to do it right now? No, not really. If we were dealing with non-real numbers, yes. Okay? But you'll see on, I think on your homework too, it says, if it is a non-real number, say so. And so that's all it wants is just, or find the root if you can. If not, state that it's non-real. All right? Questions, comments, concerns? All right? Order of operations. It's like every 6 months it pops up, and it drives me insane. And I have to stop myself from arguing with people on the internet because. But every so often you see this crap where it's like, okay, can't figure out the answer. All right? And in all fairness, for the general population, a lot of people can put this into a calculator that they have and legitimately get 2 different answers. All right? Depending on what calculator you have or even what phone you have. Okay? Because the difference in these is with programming and some assumptions. All right? Some calculators will read this quite plainly as I see it. So you would do your addition first, then you would do your and then you would do your division, then your multiplication. Okay, so the multiplication would come last, and that's kind of the most that's the right way to do it. But problem is that some calculators read this and they assume. Let's try that again. Okay, they assume because of this division, they put this whole thing in a group, and then some calculators read it as this, which would give you a different answer. Okay? It's a programming difference. Do I agree with it? No. Am I in charge of it? No. But what I do know is that proper understanding of the order of operations can, 1, prevent you from looking like a fool, but 2, then it just comes down to semantics of what was the interpretation and hopefully being able to avoid vague statements like this that caused this issue in the first place. Okay? So, order of operations tells us specifically how we should approach different problems. Okay? Always start with your grouping. All right? Parentheses, brackets, absolute value. If you have operations inside of a radical symbol, any type of grouping needs to be evaluated first. And inside those groupings, you do your powers, your roots, your absolute values. Once those are evaluated, then you go to multiplication, division. Multiplication, division have to be done at the same time from left to right. Okay? So just like in this last one, all right, I've got division and then multiplication. So I need to do division before I do the multiplication. Okay? So it has to go from left to right. And then same thing with addition, subtraction. Whatever shows up first, you do that first. Okay? In order from left to right. So In this first example, I've got 5 times 9 plus 2 times 4. So what's the first operation I'm going to do? 9 times 5. The second operation I'm going to do is 2 times 4. So 9 times 5 to get me 45. Okay, so 45 plus 8, add 53. Okay, not so bad. All right, multiplication first, then our addition. Okay, now with B, what's the first operation I'm going to do? 12 divided by 4. Okay, because I have to do either my multiplication or my division. I don't know why I wrote a B. Division, and since division shows up first, that's the first one that gets done. So 12 divided by 4 is 3. Now, I'm going to need that 3 for that multiplication. Okay, because I'm not going to do 4 times 2 because I don't have a 4 anymore. Now it's a 3. Okay, so rewrite this, hopefully without causing... Nope, okay. Let's try that. 3, 4 times... Okay, so then we can go ahead and do our multiplication. 3 times 2 to get 6. 4 minus 6, or plus negative 6, gives me negative 2, okay? Looking at C, what's the first operation I would do? 4 plus 2. That's 1. That's the first one we would do. What's the second one I would do? Okay. Third thing I would do? The exponent. And then we would end with the fraction. Okay? And that's what you guys are going to do.
Oh, I'm right. I'm right.
Did you answer it?
No.
Answer it first. So we established that we have to do. That's what we established that we do 4 plus 2 first. That gives me a nice, wonderful, positive 6. Okay. Next, I have to do 8 minus 3 to get what? 5. And then we did 3 squared to get 9. Okay. 6 plus negative 9 plus negative 5. 6 plus negative 9 for negative 3. Alright. Didn't work. I wish I could change the settings for it not to try and like auto-correct my writing. It should just assume that I'm good at what I do. Because I am. Alright. And then add those together to get negative 8. Alright. Oh, goodness, this is nothing. All right, questions on that? How you doing again? See, I told you it's going to be worse. It's really not that bad. It looks ugly. I agree. But you just take it step by step. Your fractions, your numerator, your denominator are a group. So do your numerator as a whole, do your denominator as a whole, and then you can go and simplify from there. So starting with our numerator, okay, looking at just the numerator, what can I do first? Okay, so I'll simplify the square root of 9, and then after that I can do 1/2 times 10. And since these are separate, I'm okay with you doing them at the same time, because one's not going to affect the other. All right? So because I'm not multiplying anything by the 9, or the square root of 9, nothing else is happening here. We can go ahead and we can do that. Actually, let me highlight that instead. Okay. We can go ahead and do this and this in our first step. Okay. So we get 5 minus 6 plus 3. Okay. Now, let's go ahead and do a little bit on the denominator too. No need to write more than we need to, so let's go ahead and just kind of work that through. What can I do in my denominator? Okay, I can do this. What else can I do? Square. Okay, I can do those. I can't do the 3 times 2 squared yet because I have to deal with that exponent before I do that multiplication. Okay, so I can do the 2 squared. I just can't do the 3 times the 2 yet. Okay, so 5, 6 times 12. (60/6), which gives me 10, minus 3 times what? 4. Okay, 3 times 4. All right, so there's that first part. Okay. All right, now I've done quite a few things already, and I can show that all in one step. So now what can I do next with my new fraction? I can do the multiplication here. What else can I do? I can do 5 minus 6. Okay. Okay, so 5 minus 6 gives me -1 plus 3 over 10 minus 12. Simplify again the numerator and denominator. -1 plus 3 is a 2. 10 minus 12 is -2. So my fraction simplifies to -1. Okay? So it starts out looking awful and maybe a little bit intimidating. Just take it step by step and it gets a lot easier to deal with a lot quicker. Okay? So just take a breath, calm down, and just start. And then it gets easier one step at a time. All right, questions on that? I got one more slide. Pretty sure. Yeah. Okay. Again, order of operations, this time with evaluating expressions. Evaluate the expression if w equals 4, if x equals -12, if y equals 64, and if z equals -3. What do I do with all of those? Plug them in. Plug and chug. Okay? So, my expression is going to be what? To start. 5 times -12. Good.
Plus -3
Square root of 64.
5 is -12.
-12 minus 1. Okay? Go ahead and take a minute and do that one. Huh? It is an ugly number. They're beautiful in their own way. According to Kennedy.
She's not wrong. 84 over 13 is not.
$84 over 13. Beautiful, isn't it? Face only a mother could love. Got to pay really close attention to those negatives. That's why I like to put those things in parentheses, just to make sure that it's still clear that, hey, this is a separate thing. It's really easy to accidentally get a negative sign kind of continued off the plus sign. So just making sure you're very clear and concise with what you're writing so you don't have any of those issues. All right? That's it. Questions, comments, concerns? 3 out of 4 done. So tomorrow we'll finish properties. It should go a little bit faster.